Hi everyone, welcome back to a new video. In this video, we are going to talk about comparable, which is a built-in interface constraint in Go. So let's get started. First of all, what is comparable? So like I said, it is a built-in interface constraint in Go. What I mean by that is, if we are saying something is comparable, that means that that particular type supports the equal to and not equal to operators. It is much more easier to explain with code. So let's do that. Let's write some code. Create a main.go package main. Let's import fmtl, most probably need it. Yes. So comparable is mostly used with generics. So we'll also do the same. Let's create a function that is called contains. And for now, let's not use generics. Let's say there's this slice, which is of type string, and an item of type string. What this function does is it basically returns boolean depending upon if the item is present in the slice or not. So we can do for I index and value. We don't need index actually, so let's remove index. Range over the slice. If v double equal to item, return true, otherwise return false. And it is also giving me the suggestion. Okay, that's great. Actually, let's just do it this way. Yeah. So right now the thing is, I created this contains function, which tells me if this particular string is present in this slice of strings. But what if I need something for an integer? I can't do that, right? Because contains is explicitly stating for string or slice of string. Now for that, we have generics. So we can simply define a type over here, t, and let's say it could be int or it could be string. This would be t, this would be t, and this should be int. Yeah, if I run this, then I can get the solution or the answer for string as well as for int slices, which is great. What if I want to add more of these here? We can keep using this, but the better way of doing this is to use comparable. Sorry for that. And it still works. Now, the thing is, what is comparable then? Comparable basically is a type constraint, like I said, which means that it can fit in types which are compatible with equal to operator or with not equal to operator. So what all types do comparable support? Here is the list. So these are the types that comparable supports. So booleans, integer, all the integer types, floating points, complex numbers, strings, channels, pointers, etc. All of these are comparable. There are some conditions for interfaces, for arrays, and for structs to be comparable. We'll talk about that later. But this is the idea that comparable is a built-in constraint, which basically means that this particular type T should satisfy or should be able to be used with a double equal to, a equal to or a not equal to operator. Now the question is, why do we need comparable? Why not just say an empty interface over here? Why not just use any? If we don't know what any is, it is basically an empty interface. So anything, any type is any, as in there is no type constraint. There is no constraint on what the type T would be. It could be anything. If you want to know more about any, I have a video on that. You can check that out. But let's move ahead. What is the problem with any here? If I try to build it, go, you can see it fails to compile. It gives us this error, invalid operation, incompatible types in typeset. Now, why does it say incompatible? It is completely compatible. This is a slice of string and this is a string. This is a slice of int and it is an int. So they can easily be comparable, right? But if I put it any, it doesn't work. If I put comparable, it does work. The thing is that the compiler itself, when it reads this function, it checks, is generics being used, and if the generics is being used, what is the type constraint in that case? If the type constraint is any, or if the type constraint is something, and there double equal to, again I'm saying double equal to or not equal to operations are being performed, then this type cannot be not comparable. I hope I am clear here. What I'm trying to say is that if the compiler reads this function and checks, okay, this does have a equal to operation or an equal to operator. So in this case, the type constraint should be comparable. Now this could be literally comparable, or this could be int with string, that is also fine, but it should be something that is comparable. Why is that so? Because if we do any, and for example, compiler would have allowed this. Problem with that is any means this item could be anything. So this item could literally be a channel. This could be something like, a better example would be slice of function, an item function. Does that sound good? No, right? But if you check type any, function does satisfy type any. So that's the problem. That's why this should be comparable, and that's why Go decided that the compiler should itself check, should read the function and itself check for the type constraint. You can obviously have another function like give me first item. Exactly. Yes, this is what I want. And here any is perfectly fine. This will not give any issue while compiling. Yeah, it works. And we can run this as well. Perfectly fine. Actually, we didn't use it, but anyways, it works perfectly fine. Why is it so? Because, like I said, compiler when reads the function, it checks, is this function performing any equal to or not equal to operation? It does not. So in that case, any is perfectly fine. We are just returning slice, so that is perfectly fine. But if it is something where we want to compare something, then only comparable can be used. Now, another interesting thing about comparable that you should be knowing, and it is a very famous interview question as well, is that for a map, the keys part or the keys of a map should be comparable. That is how Go has enforced it. So a map cannot have keys which are not comparable. By that, what I mean is, you can't have something like a map with key to be slice of string and then int, or maybe like a function. Key cannot be a function, obviously, or like another map inside it which is string int, something like that. So that's what I wanted to talk about. If someone asks you that what are the possible values for keys in a map, then the answer is comparable. All the types that follow the interface constraint which is comparable, all of those types are valid, or simply all the types which are comparable are valid. Now let's talk about these ones which are conditionally comparable. Sometimes they are comparable, sometimes they are not. How does that work? So let's create a struct. Let us say comparable struct, and another one, let us say it non-comparable struct. Now, what is a comparable struct and what is a non-comparable struct? The rule here is that if the fields of a struct are comparable, then the struct is comparable. If the field of struct are not comparable, then it is not comparable. Like for example, if this is value, this is name, string, I'm just giving random words, a, int, whatever. So all of these are comparable. Yes. So this is a comparable struct. Yes, you can use it. If I do comparable struct over here, let's create another one. Okay. Yeah, this is a good example. So this is a comparable struct, and now we are basically creating a slice of comparable struct. It has got some random values, and then we are checking if this slice of comparable struct contains this comparable struct or not. And this should not fail. Let's build it. It is working fine. Let's run it as well. Working fine, right? If I change the value, now it should return me false. Yeah. So that's the thing. Since all the fields of this struct are comparable, the struct itself is comparable. But if any of the field is not comparable, like one not comparable or something that is not comparable is slice. Like you can see here, slices are not present here. So if I do like a, which is going to be a slice of int, and then you can have normal comparable fields as well, like b, int, whatever, name, string. Now if we try to use this, yeah, so this is a non-comparable struct, yes, and in this case it gives me an error. It says it does not satisfy comparable. So this non-comparable struct is actually not comparable, hence it cannot be used here. So this is basically what comparable is. Now I hope you are able to understand why I said, or why it is said that comparable is a type constraint, which basically means that that type supports equal to or not equal to operations. I'll comment this out. And that is it about comparable. I hope you were able to understand what comparable is. If you are interested in more Go related videos, then you can check out the channel. In either case, thank you for watching this one, and I'll see you in the next one.